Have you ever wondered how to make your Spring Boot applications faster and more scalable? Meet Redis, a lightning-fast in-memory data store. In this video, we'll explore what Redis is and how to integrate it into a Spring Boot application using RedisTemplate. Let's get started. Redis is an open-source in-memory data store that can be used as a database, cache, and a message broker. Unlike traditional databases, it stores data in memory, making it extremely fast. Common use cases include caching, real-time analysis, and session storage. One of the most popular use cases of Redis is caching. Caching helps reduce the load on your database and speeds up response times. Here's how it works. First, the client checks the Redis cache to see if the data is already available. If the data is found in Redis, it's returned immediately without querying the database. If the data is not found, the request is forwarded to the database. The data retrieved from the database is stored in Redis for future requests. Then the requested data is sent back to the client. This approach greatly improves performance and reduces database queries. Now let's see how to set up this in Spring Boot. Before we integrate Redis with Spring Boot, let's set up Redis. First, we need to download it. Once it's downloaded and installed, we can use the Redis CLI to verify that everything is set up correctly. You can execute the ping command, and if Redis responds with ponk, you're good to go. In order to use Redis with Spring Boot, we need to add the necessary dependencies. Once that is done, we can start configuring our application. We create a new configuration class where we need to set up Redis connection factory. This is where we set our host name and host port. We can get those from the application properties. If you set up Redis locally, by default, hostname will be localhost and host port will be 6379. In the next step, we need to configure our Redis template. In order to do that, we need to define what kind of data we want to cache. Let's see how we can create that one first. We want to define a marker interface that will be implemented by all of those objects that can be cached. Next, we create a class that will wrap the key and value for us. Value is the data that we want to cache, and the key is simply the key that we'll use to add it to Redis. This wrapper class is what we will configure our Redis template to expect. In the configuration, we can now create Redis template that will expect a key of type string and value of type cached object. We also set the connection factory to the one that we created earlier. We are done with our configuration class. We can now include it into the application. Now we want to create some object that we want to cache. So let's have a user class that has two properties, ID and the name. Next step is to implement a JPA repository. This is a repository that would get us the data from the database. For sake of simplicity, I will just have a dummy implementation, but you can feel free to implement the real deal. Here we define a map of users and populate it with some dummy data on post construct. We also define a method that will get us a user by the forwarded name. With that done, we create a user service that will inject our JPA repository, and we'll also have a method to get the user by the name via the repository. Now we create a REST controller that will use the user service to get the user we need by the forwarded name parameter. With this done, we are now able to query our users from the database. But since we want our application to be performant, we want to implement some caching. We start with implementing our marker interface to our user object. This will allow us to cache it via Redis template. Now we create a caching service where we inject the Redis template bean. We also define a type of object that will be cached by this service. In our case, this is anything that implements our marker interface. Keep in mind that Redis template will not take this interface directly, but rather a wrapper object we created. In order to avoid issues with data being overwritten in case of non-unique keys, we augment it with the type name. This will make sure that the keys are unique between different objects we want to cache. Now we add a method that will be used to cache an object. It will expect the key, type of the object we want to cache, and the object itself. We wrap the key and the object and use Redis template to cache it. Next step is to add a method which will be used to read the data from the cache. It will have the return type that equals to the object we cached and will take in the key and object type as parameters. Here we also use Redis template to get the data from the cache. Data we get back from Redis first needs to be unwrapped. This is where we also handle any potential issues. Now we can inject our caching service into the user service and change our getByName method so that it first looks for the user in the cache. And if none is found, it fallbacks to the repository. But also additionally, it adds the found user to the cache so that with the next call, the user can be fetched from the cache directly. And that's it. You've just learned how to integrate Redis with Spring Boot using RedisTemplate. Redis can greatly improve your application's performance by reducing a database load. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon for more tech tutorials. See you in the next one.